begin by going over the homework. So everyone, if you could open up your homework, that would be great. I think one person didn't do the entire homework because it was a bit confusing with all the sub options, so that's fine. All right, so I have it starting the screen share. Today, I think after we finish the homework, we're going to do speed, and then we'll be done with the first part of the book, which means the 6A workbook, 6A textbook, I mean. We're basically going to be done. We're going to do some review, and then we're going to move on to the next textbook. Just a heads up, there is no class next week or the week after. But unfortunately, there will be a bit of homework. Not that much. It's not much, because you do have 3 weeks, to be fair. Let's see, review C. All right, let's see what questions you guys had trouble on. I'll go over the percentage questions on exercise 22. And I'll go over some of the word problems in review C. All right, so starting off, I'll go over the word problems. Okay, so starting off with review C, I'm going to go to the word problems. I think we're going to start on number maybe 27. Let's see how you guys did on those. 250. All right, I think I'll just go over the word problems. Got it. First off, if this wants to load for me. All right. Overviews in order. The first one, 3 boys collected 75 grams of newspaper. This is collected. I think we did this problem in class, 3 boys, and there's 2 boys collecting 30. Find the average weight. So what we can do is we can add all the weight together to figure out the total weight, and then 5 kids got 105 basically, because that's just combining these 2. And then 105 divided by 5 would get you 21. So the answer to the first question should be 21. And by first, I mean 28, question 28. For the next question, this is question 29. I'll just label them so you can figure it out. Alex sold 160 oranges and 90 apples. Each orange he sold for, wait, that was too much. He sold 5 of them for the price of $1.20. And then he sold the dollars for 3 of them at the price of $1. And how much money did he receive? Well, let's do these in 2 steps, all right? So first off, how much money did he make for oranges? Well, if he sold them in groups of 5 and he sold 160, that would mean he sold 32 of them. And if he made $1.20 each batch, then that would mean in total he made, if this won't load for me, 38.40. That should be the answer. Just checking. Yeah, that looks it. And then for apples, 90 and in batches of 3. Then he had 30 batches, and then he sold them for $1 each. And then we add these together, and we would get $68.40. So $68.40 should be the answer. If you have any questions on specific ones, I will go over them. But For now, it looks like I'll just continue with this. So let's see. 29, 68, 40. All right, yeah, looks like you guys did fine with the rest of the word problems. It was just those two in particular, actually. So we don't need to do the bottom two. You guys did fine on those. I'm going to quickly do exercise 22, and then we'll move on to today's lesson. Exercise 22 is in the workbook. And the first question is, there are 42 boys and 24 girls in a chess club. How many percent more boys than girls are there? So first, let's figure out what one person equals, right? Because if we're putting it into a percent, we know percent is really, percent means out of 100, right? So we can put this into a decimal or a fraction. I think we're going to make it into decimal because they get a fraction. We'd have to put it over 100, which is pretty difficult. So yeah, point is, we're going to make it into a decimal. How are we going to do that? Well, 42 boys and 24 girls. That means in total, there are 66 people. 66 people. And if there's 66 people, then that means one person equals how much of a percent? Well, we know one person would equal 100 divided by 66 of a percent. Well, not really. I'll put the exact thing. Yeah, so a single person is equal to like 151 repeating, 1.151 repeating. The line above just means that the number goes on for infinity. So 1.51 with this is equal to 1.51515151 ... because it goes on forever. Now, how many percent more boys than girls are there? So we're going to figure out how many more boys there are than girls. We get 18. So if one person equals 1.51%, 18 people equals, one sec. You can use a calculator for this, by the way. The answer would be 27.2727% repeating. So yeah, you can probably solve this as a fraction as well to get a cleaner number, but the answer is basically this. Next question, there are 400 students in a school hall. 240 of them are boys. How many percent more boys than girls are there? So this is a very similar problem to the last one. Once again, we're going to start off by figuring out what does one person equal. One person is equal to, so basically, if like the total is 100% and 400, but it would be 0.25% per person. How many percent more boys than girls are there? Well, let's figure out. If there's 400 total, and there's 240 boys, that means we can do subtraction, and we get 160.
400 students in school hall. 我不知道我做对不对，你自己看，他都讲了。
Candace, you're unmuted. Do you have a question?
Oh no.
All right, and just I'll mute you. Oh, sorry, I have to mute. Yeah. So if there's 160 girls and 240 boys, then how many percent more boys than girls are there? Well, how many more boys than girls are there? There's 80 more. And once again, we figured out one person equals 0.25%. So what does 80 people equal? 80 people would equal 0.25% multiplied by 80, which is 20%. Yeah. So the answer would be 20% more. The next question is very similar, I would assume, because these all seem repetitive. Cooked you 6 gallons of cooking oil last month. She used 15% less this month. How much cooking oil did she use this month? All right, so if you use 15% less, that is the same as multiplying the number, which is 6. We're going to multiply it by basically, how do I put this? So 15% equals 0.15, right? Because once again, percent means out of 100. So Yeah, so 50% is 1500ths. So if you use 15% less, then that means we're multiplying it by 1 minus 0.15. Because that's the normal thing that she uses, which is 6 in this instance. And then we're subtracting 15%. And so this is the same thing as 6 multiplied by 0.85. So in any question where it's 15% less or discount, right, words like that where you're subtracting, you minus 3% from 1. So in this instance is 0.15, and then that's 0.85. And then 6 multiplied by 0.85 is 5.1, I believe. Let me check that quickly. Yeah, it's 5.1. So this would be 5.1 gallons. We got to have the unit. And that would be the answer. The last question for this is Scott earned $600 in January. He earned 14% more than in 14% more in February than in January. How much did he earn in February? Well, what's our base price? What's the base amount that he earned? The original amount is 600, and to multiply by and to earn 14% more, it's the same idea as the one above. The same idea as the one above, except instead of subtracting, we're adding because it's more instead of less. So we're going to multiply this by 1 plus 0.14. This is the same thing as 600 multiplied by 1.14. And 600 multiplied by 1.14 is, give me a minute. The answer is 684. So this is how much he earned in February. Just a separate question. This is not the question, but if this question said he earned 14% less, then the solution would be 600 multiplied by 1 minus 0.14. And that would be 600 multiplied by 0.86. And then we would get whatever the answer is, which is 516. So that's just how you change less to more, right? Moving on. We are on the last unit of the textbook, so to speak. Like this is the first textbook. There's 2, but we're on speed now. Speed is, in my opinion, one of the more difficult units because there's a lot of words which sound similar but are different. We're going to start off with some basic multiplication. So these are like the most basic of speed problems. They're not even really speed problems, they're just multiplication. Once I can find a good one, I will send it. Let's see. All right, this one's decent. All right, so solve this problem. I'll send me the answer in chat when you complete it. So I'm getting some answers which are correct. However, I just want to remind you that it's kilometers, not miles. Like I mean, like in this question specifically. I'm not saying like always convert it to kilometers, but like here, if it tells you kilometers, you know, then give the answer in kilometers. Good job. One more answer and then we will move on. All right, so moving on. This is a pretty easy question. I'm not really going to explain it. Let me get a bit more fancy though. Next question. John started cycling at 7:30 a.m. by 9:30. By the way, I want you to express the answer in miles per hour. For this question, it's miles, right? Like we're going to be changing units a lot, so make sure to pay careful attention to the units in the question, because that's the type of unit that you want to be giving your answer in. Wait for one more answer and then I'll move on. Just figure out how we can kind of make this question similar to the last one. I just want to make sure everyone understands this. I'll quickly go over it because I think we might have had a mistype or something, but just to be safe, I'll go over it. If he covered a distance of 20 miles, first we have to figure out. So this is like the first principle that I'll go over. Speed is equal to distance over time. For example, if a bus, looking at question 1, if a bus traveled 220 kilometers in the time of 4 hours, then we divide this and we get 220 divided by 4, which is 55. So we get 55 kilometers per hour. In this question, speed equals d over t. Notice how I use s for speed, d for distance, t for time. What does s equal d over t in this equation? Well, you don't know this. We know the distance. It's 20 miles. We know the time. It's 2 hours because that's the difference between them. If we divide 20 by 2, we get 10, and then it's miles per hour. So the answer would be 10. So now I'm going to give a part B to the question. So it's the same question, but I'm just going to add a bit. This is more like it becomes a bit more complicated now that I add this. I want to highlight both of these. Give me a sec. All right, this is good. All right, so it's the same question, but it's a bit more complicated now. And just to make it prettier, I'll let that side out. All right, so it's the same question as the previous one, but I'm asking you if he cycled an additional, if at the same pace he went 15 more miles, what would his new time be? Okay, interesting. Two answers so far, both correct, both correct. Okay, I'm waiting for one more answer and then we'll move on. All right, good job. So the answer is 11 o'clock. The answer is 11 o'clock. Now, the way we are able to solve that, the way we are able to figure out it is 11 o'clock is because we already figured out that his speed is 10 miles an hour, and therefore to go 15 miles at a pace of 10 miles an hour, it would take you 1.5 hours. And if the time is 9:30, and you add 1.5 hours, or in other words, 1 hour and 30 minutes, we would get to 11 o'clock. So the answer is 11 o'clock. So yeah, the questions are all going to build on this idea, and they're going to get a bit more complicated. The next question, Colin took 4 hours to drive from town P to town Q at an average speed of 75 kilometers an hour, blah, 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 blah. So this question might be a bit daunting to see this big of a question immediately. So I'm going to go over the parts of it. This is time P. This is time Q. It goes this way, and this is crooked. Give me a sec. Goes this way, and he goes back. And the bad thing, Jesus. Okay, 4 hours. Took him 4 hours to go this way, and it was at a speed of 75 kilometers an hour. And on the way back, he drove at an average speed of 60 kilometers an hour. And it's asking how long did it take? So to solve this question, I want you guys to first figure out what's the distance from time P to time Q. And once you figure that out, plug it into the second part. So it's like a two-part question. I'll wait like one more minute because people might be having trouble. All right, so I'll start to go over this because only one person's gotten it. I'm going to erase it. Oops. Should be erased right now. We're going to erase this, and we're going to erase this. All right, so if it took him 4 hours to drive from time P to time Q at an average speed of 75 kilometers an hour, that means that if he goes 75 kilometers an hour for 4 hours, he traveled a total distance of 300 miles. Keep in mind the time P, that when he goes back, he also goes from time Q to time P. The distance is the same. Therefore, the distance both ways was 300 kilometers. On the way back, it took him 60 kilometers an hour, which means that why does it erase so much every single time? Which means it took him 5 hours, right? So what is a trick that we can use to solve these problems? A trick that we can use is every single time that we see one of these problems, we think to ourselves, speed equals distance over time. And then we try to fill it out. If we knew on the way over, okay, so I'm going to set up 2 speed equals distance over times. All right. So this is P to Q. This is on his way there. And this is Q to P on the way back. So speed, and then I'm going to have my example up here. Speed equals distance over time. So what was our speed on the way there? It was 75 kilometers an hour. I'm not going to put the units because we already know the units and it's like right up here. I'll just assume like for the problem that you don't really need to know. And then it took him 4 hours. And then this is just an equation that we can solve. We have to solve the top number. What number divided by 4 equals 75? Well, that would be 300. Once we figure that out, we know that for the second equation, we know the speed, it's 60. We do not know the time. That's what the answer is. And we know the distance is 300. So we know the answer is 5 because we can fill it in. I'm going to go over this again because it's like an important example that's going to help us solve all our future problems. This is the equation we start with, all right? These are the equations we start with. We cannot solve the answer immediately because we don't really know anything, okay? We don't really know anything about the equation, so we can't really solve it. However, we can if we do this. We can if we solve this equation first, get 300. We plug it in over here because these two are the exact same amount, and then we can solve it for 5. So that would be how you solve this question. It's a bit more difficult, so to speak, but it's fine. I'm going to send another example. Try to apply the same stuff. Once again, all you need to know is speed equals distance over time. Like, that's really the only important thing, I'm going to be honest. Leave for 1 second. I'm going to have to grab something. I'm going to grab some water. You just like send me the answer in chat. All right, so I've got one answer. Continue on. I think a lot of people are mistaking this. A lot of people are doing this a bit wrong. The average speed of the motorcyclist was 35 kilometers an hour. This is not the total amount. So once again, this is the same. This is a similar question to the previous one, where you have to do the first part in order to solve a variable, which you will use in the second part. I would like. I'm going to send. If I send you a message in chat, redo it. There's only one person's gotten it correct. Everybody else has to redo it. Yeah. Mhm. All right, someone's reading it and got the correct answer. Very good, very good. Yeah, so just redo it until you get the correct one. All right, that's good enough. I think we can go ahead and solve it. So once again, it's a two-part problem. First, we're going to see motorcyclist, motorcyclist, and then we're going to solve for the van. Once again, speed equals distance over time. Just remember that formula. It's very important. It's like a very simple one. It's like the simplest formula you'll ever learn, and you can figure it out by just thinking miles per hour. But it helps. The speed of the motorcyclist was 35 kilometers per hour, and it took him 7 hours. So if his distance over time, the bottom is 7. What does that mean? What does that make the top number? It makes the top number 245. The van took 5 hours. We don't know the speed of the van. That's what we're trying to solve. And we know 245, so the answer is 49 because 245 divided by 5 is 49. So that's like what our basic problem is going to look like. I'm going to send a batch of 5 problems now. We're going to start our practicing. We're going to do these practices for like maybe 10 minutes or so. Hopefully, it won't take you guys more than time. And then we'll finish up this unit because we have to. Well, no, that's it actually. Yeah. So we'll just do practice and then reviews. Great. That's great. Got it. So you guys can just work out. I'll just send me 1 to 5 in chat when you're done. All right, we got 2 answers and continue working. Good job, good job. All right, I will. I'm gonna shrink this now because one person's still on it, but I will send them the next set of questions. Once again, actually not once again because I didn't say it, but we're in the textbook right now. We're in the textbook. Yeah, we're in the textbook near the way back on practice 5A. I'll write that down. So if anyone wants to follow along with the textbook, feel free to do so. Yeah, so just start doing the next set of questions. When the last person sends their answers for the top section, I will delete the top section as well. Great job, guys. Yeah, so start working on the next set. I'm just gonna very quickly go over number 3 because it looks like it was just a misread. Here you have to figure out you gotta be careful. A lot of times when people see distance, they think it's speed. And sometimes people see speed and think it's distance because the way we write distance or the way we write speed is very similar to distance. Because when we write 420, we don't write 420 because like the way you would say it is like it's 420 miles per hour. So you say miles first, you can get confused. So the answer here would not be 140. The correct answer would be 1,260. Because if you travel 420 per hour, you multiply it by 3 instead of dividing it. So you got to be very careful which is speed and which is distance. Yeah, which one's speed and which one's distance. Secondly, I just want to very quickly go over number 5. And then yeah, I'm gonna scroll down a bit and then make this a bit bigger because we're only on number 5. Yeah, so I'll make this bigger now. Okay, so I'll go for question 5 quickly. Question 5, the train left station. So that means it would take 2.5 hours, right? But the current time is 8:30, so the correct answer would be 11 o'clock. o'clock. Am I correct? No, I'm wrong. No. Yeah, the correct answer would be 11 o'clock. Right? I'm not crazy, am I? The answer would be 11 o'clock. Yeah, because it's 250, 100 per hour, so it would be 2.5 hours to get there. Time is 8:30, so it would be 11 o'clock when you get there. Just gotta read these questions carefully. And as I said earlier, what you really need to know for speed is speed equals distance over time. We plug all the values in and we get our answer. It's pretty simple, honestly. And I'll make this even bigger. Yeah, good luck. Yeah, I'm gonna go over. If you're having trouble with number 7, just put like a question mark and move on. I'll go over it later. So we have two answers now. Yeah, 7 seems to be a difficult one. It's okay. I will. I'll go over 7. 8 and 9 seem to be giving people some difficulty. Maybe I'm a bit confused what this means. Here's this one. All right. Oh, we got another answer. All right, that makes more sense. All right, good. I'll start going over these. Number 6 doesn't seem to have given anyone. 6. I'm just gonna put the answer for 6. 6 should be 52.5. I believe so, at least. The reason is because if it takes 15 at the speed of 70, that's 15 times 70. How do I put this? Sorry. That means the distance is 1,050 meters, and if it takes you 20 minutes to go 1,050 meters, that is equivalent to going 52 meters per minute. So that would be the answer. Question 7, I will go over in a second. The last question is 9. Everyone got this one. I'll go over 7 now. If it takes 2 hours at an average of 60 kilometers an hour, that means the distance is 120, right? So once again, this is going to be an equation where we make ourselves 2 of these little setups, all right? All right, so the first setup, we have the speed of 60, and it took 2 hours, distance over time. And then the question is 80, and then it's like how long it would take, so question mark. How do we solve this? If 60 equals the distance divided by 2, that means the distance is 120, right? The distance is 120. The same distance, because it's the same amount, remember, that's how we solve it. And then 120 divided by what equals 80, the answer is 1.5. So yeah, the answer is 1.5. It's this. 8 minutes to run around a track for 4 times. That means it takes 8 minutes to go 1,600. That means they go 200 a minute. So the answer should be 52.5, 1.5, 200. And the last question is it took 2 hours, 60, so it's 120. Should be your answers. I'll just go over. You got to be very careful with reading the question correctly. All right, you got to be careful in reading the question so you can get the correct answer. It's important that you know what speed, what's distance, how you apply them. Yeah, it's very important. Now I'm going to send practice 5B questions. We're going to do, yeah, there's 7. I'm going to send you 5 questions, and then 6 and 7 are going to be for homework. Yeah. think I'll start with it. Let's see what this is going to be. There's not anything next. So let's see, we are on finish. So I'm expecting some answers sometime soon. The homework's going to be posted. So after you send your answers for these questions, you can go if I tell you to. Okay, yeah, just send me your answers first. I'll tell you if you can go. If you get them all correct, I'll let you go. That's the that's the All right, so it doesn't look like anyone else is going to be finishing these. If you are like, still working on it, I will, I'll just send the answers for now. In a minute. All right, so 430, 230. We're looking for the speed. All right, so speed equals distance over time. The time took 2 hours. The distance, when we add all these numbers, which would be 22.5 plus 42.8 plus 42.7, and then we would get the answer of 108 kilometers. That means our answer would be 54 kilometers per hour. All right. Yeah, the next question would be 2 hours. The distance is 2 hours here, it's 20. And then if his average was increased by 2 kilometers an hour, that means his average would become 12. And since we know the distance is 20, if you go 20 miles at a speed of 12 per hour, it should take you it would take you 1.666, but I'm too lazy, so I'll just write 1 hour and 40 minutes, because that is, also a valid response. I'm just gonna check to make sure. Yeah, so you gotta be, okay, once again, you guys have to really read the question carefully. How much time? They're not asking for the speed. They're asking, we know if you add 2, then it becomes 12. So how long would it take him to go 20 at 12 miles an hour and be an hour 40? I think. I just want to check. Yeah, so an hour 40, just making sure. Ben and David both cycled 24. If David took 9 kilometers an hour, that means that David finished the entire thing in 2 hours and 40 minutes. I'm just going to check to make sure that's correct. Yes, correct. And so that means if it's 20 minutes faster than Ben, then it took Ben 3 hours. And that means Ben went at a pace at 8 kilometers per hour. It took 5 minutes to walk from his house to the main road, an average speed of 46 minutes a minute. And then they're going to go to the wall. All right, so these last 2 questions, actually, we're just going to skip them because we don't need them and time's up. So just, yeah, sorry about that. We don't have any more time today. The homework has been posted. You have to finish the last 2 questions on the sheet. Keep in mind there's multiple parts. And then, of course, you have to finish the review. So basically, we're just finishing the entire textbook, and then we'll start the next one in January. So happy holidays, have a happy new year, and see you all.